Okay, welcome everyone. Okay, let's wait for a few minutes so that others can join. In the meantime, I will share my screen. Okay, if you have any other questions from the previous sessions, you can ask. And if not, then we will start the session for today's. That's all. We have come to the ends of these assignment sessions. So this is the week number 11. We are just left with one more class that will be on 25th April. Probably after that you guys have the examination for the certificates. Okay, let's just wait for 1 or 2 minutes and then I will start. So probably now you guys are familiar with all the concepts of probability and thermodynamic variables, and then today is the sort of the last. Today's session is on the last week 11 lectures, and from what I came to know that week 12 is all about assignments and all those stuff. So there will be no other lectures, and there will be grand problem solving session on week 12. On week 12, so that's it. And okay, just wait for 1 minute, and then we'll start our session. Okay, so let's start. Okay, yeah, so welcome everyone, welcome to the problem solving session of this NPTEL course, where the course ID is NOC23 CY07, and the course name is Basic Thermodynamics, Classical and Statistical Approaches. Instructor of this course is Professor Arnab Mukherjee from IIT Pune, and this is the assignment solving session of week 11. And as you all know, probably till now, that I am Dibyendu, and I am a Prime Minister's Research Fellow at IIT Kanpur, and I am doing my research in the Department of Physics. And here is the link of my website, you can follow my current topics that I am interested in, and you can also contact me. There is different contact options. You can contact me, and I'm doing my research in non-equilibrium statistical mechanics. Probably you will also get some ideas about the recent statistical mechanics or statistical physics research. And this is the link for the YouTube channel where I keep on posting all those assignment solving sessions, and there is a dedicated playlist in the name of this course, and you can check all those previous sessions if you miss any one of those. Okay, and also important thing, if you like my content and if you like my teaching, then you can leave a like or comments, and you can share those sessions to your friends. Okay, without any delay, let's start the first problem of this session. And the problem says the criteria for spontaneous change among the following is, so the criteria or the condition for the spontaneous change among the following is option A, delta G, where G is the Gibbs free energy. Delta G at constant T phi means change in Gibbs free energy at constant temperature and volume is less than 0. Option B is change in Helmholtz free energy at constant temperature and pressure is less than 0, and change in entropy at constant internal energy and pressure greater than 0, and last option is change in internal energy at constant entropy and volume. So let's do this problem. So the thing is, as you have just know, that combining first and second laws of thermodynamics we can write TdS minus du minus PdV is greater than 0. So this is true for each case. So TdS minus du minus PdV equals to 0 is for equilibrium or for the reversible process. If there is any reversible process or non-equilibrium thing, then TdS minus du minus PdV greater than 0. So for the spontaneous process, this should be greater than 0, because irreversible this is. Okay, now to write in different thing, we can write, let's say, when S, V are constant, then we can write minus du greater than 0, and S and V is constant, right? Then we can write du S V less than 0, and also we can write it as delta U. So it is just a change in notation, delta U, where S and V are constant, less than 0. So one condition we get. So this is 2. So this is correct. Let's check for others. Okay, let's check for others. So for entropy, we can write if U and V constant, then we can write TdS. U and V constant means du and dv 0, then greater than 0, and we can write, since temperature is always positive, we can write ds at uv is greater than 0. So this will be, which says that delta S at u and v greater than 0. So this is not right, right? Now Helmholtz energy A is, we can write as, that is T and P. So T and P, Helmholtz energy is U plus PV, which makes delta A equals to delta U plus P delta V plus V delta P. So that makes TdS or T delta S minus delta U P delta V Hi Mugilan.
Good evening, sir.
Yeah. So what we are doing, so this week's assignment session is based on the Maxwell relations or different thermodynamic variables and their relations, and there are different methods to find those relations effectively. And so through these problems, we will solve, or we will find those relations using different tricks, and that we are trying to do. So far, what for this problem, the problem says the criterion for spontaneous change among the following, and there are different conditions, and we have to write the correct criteria. So if we write the first and second law of thermodynamics, we can write TdS minus du minus Pdv greater or equal to 0. So where the second law comes? Second law comes from this TdS and also this inequality sign, right? So this equal sign is valid when this is in equilibrium, or this is reversible process, right? But spontaneous process is not reversible or equilibrium process. This is irreversible process. So that's why that will be inequality that is greater than 0. Now to find different conditions here, we first fixed S and V are constant. So if S, can you see my cursor? No, right?
No, sir.
Okay, just a minute. Now you see, right? A laser pointer.
Yes, sir.
Yeah. So if we make this S and V which are constant, then ds, that is delta S, that is also 0, and delta V is 0. So the only term that is left, that is minus du at constant entropy and volume, that is greater than 0. Then we can write it as du at constant S and V less than 0, and just changing these infinitesimal changes in delta changes, we can write delta U at constant entropy and volume less than 0. That we can write, right? So this option is true, but we need to check for other options, right? So for other options, we fixed U and V. If U and V are fixed, then there is only one term left, TdS. TdS greater than 0, and temperature, this is in absolute scale, it is always positive, right? So we can write delta S at constant U and V is greater than 0. So here U and P, so that's why it is wrong. And now we are trying to find A. Okay, for A. So for A, so this will be T delta S, so delta U, and P delta V will be minus delta A minus V delta P and greater than 0, right? So to make it only about delta A, we need to keep S and P both fixed. So that condition will be delta A at constant entropy and pressure, that will be less than 0. So you have followed me so far, right? So we can write only this, but here that is temperature, so this is also not true. Okay, so now G for Gibbs, so what is the form of G, Gibbs free energy? Can you say, one of you please? G.
H minus Px.
H minus Px or Pv, right? Ts, sorry, Ts,
Yes,
right?
sir.
So
Px.
H is U plus Pv, right? Or U plus Pv minus Ts. Okay. Now if you take the differential, del G will be delta U plus P delta V plus V delta P minus T delta S minus S delta T. Now there was in this thing there is TdS minus P delta V, so we can write T delta S and P delta V as like this. So we can write delta U plus P delta V minus T delta S is equal to delta G minus V delta P minus S delta T. So the spontaneous changes comes then minus delta G minus V delta P minus S delta T, that is greater than 0. So what we have done is we just write these equations in terms of this, and our spontaneous, to check the spontaneity we have to check this. So I just take the negative, so this will be that. And now if you take this, then it becomes delta G plus V delta P plus S delta T less than 0. Okay, now to make it delta G, we can write in the same fashion, keeping P and T fixed. We can write delta G at constant P and constant T equal to 0, that is right. So here delta T and delta V is there, so this is also not correct. Okay, so the only correct option is this one. Okay, any questions so far? All clear?
So can you move on to the next slide?
Yeah, sure. Yeah, here.
Sir, I think there will be delta G minus V delta P plus S delta T.
Yeah, sure. So this is the same thing, right? I just want to do this thing. This is minus. So the same thing. The main. So there is some algebraic mistake, but if you take T is constant, so that will make it 0, right? Okay.
Okay, sir.
Yeah.
Yes, sir.
Okay. So this is the same thing, because anyway we are going to make delta T is equal to 0, because keeping T fixed. That's why the sign change doesn't make any blunder, but it is just sign mistake I did, so that's it. Okay, so moving to the next problem. Next problem says del H del P means slope of enthalpy versus pressure curve at constant entropy has the dimension of option A volume, option B pressure, option C temperature, option D heat capacity. Okay, so now Mugilan, say what would be the correct option?
I'm not sure, sir.
Okay, so let's just do it together. Okay,
Yes, sir.
so as you've just said few minutes back that this is enthalpy, which is U plus PV, right? Now if you take the differential delta H dH, that will be du plus P dV plus V dP. Now du plus P dV, this is TdS, right? So TdS plus V dP. Now since H can be written in terms of differential S and P, we can write H as H is a function of S and P. Now expand it in terms of differential. Del H del S at constant P is ds plus del H del P at constant S is dP. Okay, so now comparing equation 1 and equation 2, we can write del H del S at constant P equal to something and del H del P and constant S equal to something. Now Mugilan, you say what will be del H del S at constant P? Just compare these two.
So del H by del S will be equals to temperature, that is T,
T
and del H by del P will be equal to volume V.
volume B, right? So the option will be,
Yes, sir.
correct option will be volume. Okay, now I will give you one mnemonic diagram to remember all those things. So this is this so G this is, if you remember this mnemonic diagram, then it will be easier for you to remember all those things. So this is one mnemonic you can write as good physicist have studied under very fine teachers. Okay, here F is similar as A. So sometimes in some book there is F, in some book there is A. Okay, now to write this, it's same as Cartesian coordinate. So right hand side, this is positive, this is negative, this is positive, this is negative. And to write any differential of anything, we have to write in terms of the the neighbors two variables. So the neighbor variable of G will be
Pressure,
and
temperature.
temperature. So in the case of H, then what will be the, so we have to write is like this: del H is equal to then that will be dP and ds. And to make it the same same, this is, since this is an energy, so we have to multiply this this differential with respect to its canonical conjugate variable. So P's canonical conjugate variable is V and S canonical conjugate is T. So canonical conjugate is canonical conjugate which has x and y, x, y will have dimension of energy. Okay, so this will have dimension of energy. So in this way you can easily write the any kind of this energy G, H, U and F, these free energies in terms of other intrinsic variable. So or like this variable P, S, V, T, which are like the common thermodynamic variables. Okay, clear?
सर इसमें जो आपने एक सेकंड मुझे ये बता देना डेल एच अपॉन डेल पी
Yes.
और एक में जो बी आया ये कैसे है?
This del H del P at constant entropy is equal to V, ये कैसे आया है? Your question is that, right?
Yes sir.
Okay, so first we know enthalpy is written as U plus PV. Okay,
Yes sir.
now let me just laser point, bring the laser point. So now we are writing in terms of differential. Okay, now we are writing as differential. Now dH, that is a differential, we have to write now differential of U is du, and differential of PV we can write PdV plus VdP. Are you with me up to this point?
Yes sir.
Okay, now du plus PdV, that is TdS, right?
Right.
Okay, so now that will be dH is equal to TdS plus VdP. Now we have
Yes.
got a nice differential with respect to two variables S and P. Means H is a function of S and P. So whenever you have written one variable or one thermodynamic variable in terms of other thermodynamic variables and their differentials, you can write that as function of S and function of those differentials, right?
Yes.
Now, so now looking at this equation, you can write this H as a function of S and P because here the differential as ds and dp. Now any function, if this is a multivariable function, we can write del H del S at constant P at ds, that is one with respect to a derivative of 1 and keeping 1 fixed, plus del H del P at constant entropy times dp.
Yes.
Now compare these two equations, equation 1 and equation 2. So here dp, here is also dp, and here v, here del H del P at constant S, here del S and del H del S as constant P, and this is T. So now just comparing these two we can write it. Okay?
Yes, yes.
Okay. Okay, let's go to the next problem. So the next problem says the Maxwell's relation derived from dg v dp minus s dt. Now if you remember correctly, this is the Maxwell we have just written, right? dg. So as Mugilan just few minutes back said, now following this mnemonic diagram, we can write dg equal to dp times its canonical conjugate plus minus dt times its canonical conjugate, because we have said that if you go in this direction, that is minus, if you go in upwards, that is plus, if you go in the right direction, that is positive, if you go in the left direction, that is negative. Okay, so now you can write dg. So let me write it. So same thing, dg will be dp and dt. Now this is minus because this is in the lower, and dp is plus. Now p's canonical conjugate is v and t's canonical conjugate is s. So dg will be vdp minus sdt. That is here, right? Same expression, right? dg is equal to vdp minus sdt. Now the question says the Maxwell's relation derived from dg equal to vdp minus sdt is. Now I want you guys to attempt, and then you said now then you will tell me what is the answer. Okay, should I expect that? Or should I give you one hint? Okay, I will give some hint. Okay, now one information is this free energy A, G, H, U, these are all exact differentials. Okay, that is one thing. Now dg, you have written vdp minus sdt. Now from the previous thing we can write g as g of pt. Now we can write del g del p at constant t dp plus del g del p or del t at constant p will be dt. Now just compare these two, then v will be del g del p at constant t, and s is minus del g del t at constant p. Okay, now exact differentials, let's say one exact variable b and it is a function of x and y. It has one good characteristics, which is del b del x at constant y, and if you del e take the derivative again with respect to x, that is eventually del b del y at constant x del x times y. That means these partial differentiations or this partial differentiation does not depend on the order. So if you take the partial differentiation first with respect to x and then with respect to y, that shouldn't depend, or that should be equal if you take the differentiation first with respect to y then with respect to x. Okay, now with given this information, please try to get the relations. Okay, Mugilan and Sachin, both of you try. And also Mugilan, in JAM and on all those competitive exams, this kind of problems often comes, and they actually form a good amount of questions. And if you are good at it, you will score heavily on those things. And these things actually depend on your practice. If you play around those variables and if you remember all those mnemonics, then you will do it very quickly. Okay. Now Mugilan, are you trying? Sachin, are you trying?
Yes.
Okay, good.
Yes, sir. Sir, option C.
Option C means del V del T at constant P is equal to minus del S del P at constant T.
Yes, sir.
Okay, Sachin, you? Sachin? Sachin, are you there? Hello. If not, then I will solve it, okay? Mugilan, you are right. Completely right, okay? So, as I've just said, then doing this will make del first del G del P at constant T. Now you have to take the derivative with respect to T, okay? And this is with respect to then P will be equal to del G del T with respect to P and del P of that with respect to T. Now del G del P at constant T, del G del P at constant T means this, so that becomes del V del T at constant P is equal to del P del G del T at constant P means minus S, so minus S, that is constant T. So that makes del V del T at constant P is equal to minus del S del P at constant T. So option C is correct answer. Okay, no problem with that.
Okay.
Okay. Okay. Now, what I also try to extend here is whenever you will, whenever you will try, whenever you will try to find the Maxwell relations, first try to write free energies in exact differential form, okay, and then get its variable dependency. Means that function A will be function of x and y, or let's say B because A has other meaning x and y. Now if you do it for H, what is H? H is enthalpy U plus PV. So del H or dH is du plus PdV plus VdP. So du plus PdV is TdS plus VdP. Now you just can quickly write, right? Then T will be del H del S at constant P, and V will be del H del P at constant S. Now take other derivative, del P of T at constant S means del P del H del S at constant P is just reverse the order of differentiation, and that will become del H del P at constant S delta S at constant P, and that will become del S del H del P at constant S is V, so V at constant S or P, sorry, so that become del V del S at constant P. And there is a good diagram or mnemonic diagram SPTV. Okay, what is SPTV diagram means? We can write different in style. So let's say TPS. So T will go like this, TP, and the constant is S. So this is in this way, and it becomes VSP. So VSP. So, and since this is the final displacement from T to S is in this direction, and this P to P in this direction, both are negative. So we will count as, well, this is a mnemonic thing. This shouldn't be. This is a, mnemonic means this is a method to remember this thing easily. So we will take as if the final displacement along in the upward direction, that is negative, in the lower direction that is positive. Since here both these two changes in upward direction, so that makes it, so that will be two negatives means that will be a positive. So let's say you want to do from this to this, S to V2, so that becomes like this, or V2 this one, so this will become, sorry, okay, so V2P. Now, sorry, here this is jumbled up. Let's say here, okay, SPTP. So VT and P here, and SPT. So here this is in upward direction, this is in lower direction. So we can write is del S del P at constant T equal to minus del V del T at constant P. The same thing, right? So in this way you can remember those things easily, and you can solve those problems very easily. Okay, any problem so far? All good? Mugilan, Sachin?
Yes, sir.
Yeah. Okay, so if that's it,
सर
yeah.
ये भी समझ में गया, लेकिन जो आप ये बता रहे थे ना कि ये एस पी और बी टी से मतलब इनको डायरेक्ट वो करना, ये पता नहीं चला जो आपने लास्ट में बताया.
Okay, this thing, right? So if
Yes.
you see those lectures, then it will be useful. But I will tell you the main scheme. Scheme is you have to write SPTV in this way. Okay, SPTV. You can remember it as special program on TV. Okay, so special program on TV, and this is the way you have to write it. Now to draw this arrow, this means which is the numerator, which is in the denominator, and which is fixed variable. So here let me draw the pointer. Here numerator, this is S, denominator P, and variable is T, right? So that's why that I marked this arrow as from S then T. So for VTP, similarly, this is the numerator, this is the this is the denominator, this is at constant, so VTP. Now there will be one sign. Sign is assigned as if from the final in the numerator to what do you say, numerator to t means here the constant thing, that is in the downward direction, that is positive. If the same is in upward direction, that is negative. That's why del S del P at constant t means S in numerator, P at denominator, t is constant, that is positive, and VTP, V is that is in upward direction, so del V del T at constant P, that is minus. So similarly for this thing means TPS, so TPS, so starts from here, TPS, that will be delta T delta P at constant S, that is positive, and SVT, VSP, so starts from here, VSP, that is in upward direction, that is, it is also in upward direction, so both will be negative, but negative will be positive. Okay, understood?
Okay. Yes.
So in this way you can write any kind of Maxwell, the 4 Maxwell relations easily. I have shown you here 2, because here the problem was for 1, but I have shown you for 2, but you can write for other. So A and what do you say, U are left. Also one thing, if you realize that this is also written in terms of that exact differential, so G is P and T, so that's why we can write G here, and U is how U is written. U written as U a function of S and V, so U will be here, so starts from one this direction and one that direction. This is SP, SP is here, S and P, so that is H, so this is H and this is A. Okay, so you can easily from this diagram also write U is a function of U, S and V, G is a function of G, P and T, and A is a function of A, B and T, and H is a function of H, S and P. Okay, this is the relation. Okay, so let's go to the next problem. Next problem says, consider an ideal gas at volume V at temperature T and pressure P if the entropy change in S, that is change in entropy, then del P del S at V is equal to that. Now I want you guys to, using the mnemonic diagram, please answer me. Sachin, you do it. Mugilan, you also try, but I want the answer from Sachin. So this is easy. Means you will first write the diagram SP T V, and now write. Sachin, answer me. Hello.
इसका आएगा आंसर ये वाला जो इसका थर्ड है ना, थर्ड
Minus del T del V.
अपॉन डेल बी. हाँ.
Okay, right. Mugilan, are you agree? Do you agree with Sachin?
Yes, sir, I do.
Okay, so now Sachin, help me in drawing this curve. So from P, so we will start from, for this we'll start the graph from P here, right?
Right.
And then it ends here, right?
Yes.
Now for the second graph, from where it will start? SVT where?
इसमें VTP
VTP.
नहीं, इसके जो एरो नीचे की साइड है तो इसमें मतलब माइनस आएगा अपोजिट
that
डायरेक्शन में।
that okay. I am asking कि अगर इसका जो इक्वल होगा वो कहाँ उस डायग्राम के लिए कहाँ से ड्रॉ करना पड़ेगा? So we have to draw from here, right? Or here, or here, or here, where? We have to draw from here, right? T, because it starts from here, so next relation will start from here. So it will go from here to here. Now for here, this is downward and this is upward. So as you have just know that first delta P, delta V at delta V, delta PS at constant V. So this is positive. Now delta T, delta V at S, this should be negative because this is upward and this is downward, and we said that for downward it is positive, for upward it is negative. So this is the correct answer, right? So the correct answer will be option 4. Have I correct mark? Yes, I marked it. So correct answer is this, right? Right? Anyone? Please respond.
Yes, sir.
Yeah.
Yes, sir.
We also know that this is a one kind of trick that we have to do for fast calculation, but to know it how the calculation comes, we have to write u as function of s and v. Probably I have done it in the no, I didn't do it, so I will do it here. U is a function of s and v, as you have know, so you can write del u del s at constant v dv plus del u del s at constant, del u del v at constant s ds, this is ds, this is dv. So now del u del s, so du is tds minus pdv. So del u del s at constant v is t, and del u del v at constant s is minus p. So we can write it as t del s minus p dv. Now we know we will take the other variables. So now respect to v, del v del u del s at v at constant s is equal to del s of del u del v at constant v. So you can write as del u del s t, so t del del v at constant, del u del s at vt, so del t del v is equal to minus del p, because del u del v is minus p, del p del s at constant v. So thus minus sign will be there, so del p del s v will be minus of that. Okay, so it comes from the internal energy, this internal energy function. So there are 4 energy functions. One is Gibbs free energy, Helmholtz free energy, normal free energy, this is called internal energy, and other one is enthalpy. Okay, so that's it. So for problem 5, the maximum non-PV work that a system can perform at constant pressure is option A, delta H, enthalpy, delta G, Gibbs free energy, delta A, now Helmholtz free energy, delta S entropy. Anyone? What should be the answer?
Del H.
Del H. Okay. Okay. Mugilan?
So I'm not sure, but I think it's delta S.
Mugilan, this is one problem. So delta S has the dimension of energy.
No, sir, it doesn't.
So this option is not valid, right?
Yes, sir.
Now you answer.
I too feel it's delta H, sir.
Delta H.
Yes, sir.
Okay, but if you probably heard the lectures or if you follow the lectures, you probably know that this is not enthalpy, this is Gibbs free energy. So let's do the calculations and then see. Okay, if let's try. Okay, so G, Gibbs free energy, is U plus PV minus Ts. Okay, so this delta G becomes delta U plus P delta V minus T delta S minus S delta T. Now at constant pressure, sorry, one term is missing, P delta P. Constant pressure, this term goes away. So only term less delta U, P delta V minus T delta S plus S delta T. Now you can write delta U minus T delta S plus P delta V and S delta T. We'll keep temperature is also fixed. Okay, so this is also 0, so T is constant. So only thing left, delta U minus T delta S and
Minus del PV.
minus
PDV.
that is right. Okay, so T delta S is equal to delta U plus delta W
PDV.
delta no dW. So this is for, you know, when you're trying to write in terms of work and energy. So this will be total delta W, total work, and PdV is dW for mechanical PV work, right? Right? So this is PV work, means dW PV is minus P delta V, right? So this amount of work is not due to, so this is delta W non PV. So this amount of work is not due to mechanical work. So this kind of work is something like, if you are like surface tension, like one charge, some charge molecule is there. So in the external field, they will interact with the external field, and due to that, there will be some work done on the system. So this kind of work is not mechanical work, right? These are electrical work or electrostatic work or magnetic work, this kind of work. So this is non-PV work, right? So this comes here. This is pretty simple calculation. So delta G will be that. So this is delta G, maximum non-PV work that a system can perform. Okay. Hello.
Yes, sir.
Okay. Okay. Let's go to the next problem. Next problem says if alpha is the coefficient of thermal expansion, then delta T delta V means delta T delta V at constant pressure is equal to first 1 by alpha V, second option minus alpha V, third option 1 by V. Sorry, third option alpha, fourth option 1 by V. Okay, can you guys do one thing? You can solve the problem. In the meantime, I can take 5 or 6 minute break. Okay, my throat is very bad. Okay, is it okay?
Okay. Yes, sir.
Hello.
Yes, sir.
Yeah. So which option is correct? Okay, let me do it. So alpha, which is thermal expansion coefficient, which is 1 by V del V del V del T as constant P. So that makes del V del T as constant P alpha V. So just take the reciprocal, this thing, just do the change, that will be 1 by alpha V. So 1 by alpha V is the correct option. Okay, no problem so far. Okay, okay. Now
एक बार और बताना, वो मुझे समझ में नहीं आया
इसमें, so thermal expansion coefficient is defined as this: 1 by V del V del T at constant P. Now del V del T constant P, if we take this V here, then del V del T at constant P will be alpha V. Now just make it just reverse of this, that is del T del V at constant P will be 1 by alpha V, just taking the reverse of this, right?
ओके सर जैसे अगर हम इसका जो डेल टी अपॉन डेल वी कांस्टेंट पी है, अगर हम इसका मैक्सवेल रिलेशन टाइप से वो करें जो हमने एसपी वो किया था टीवी, तो इस तरह से इसका किस तरह से करेंगे?
So S P T V. Now T V at constant V. So that is not, that we cannot write, right? So in Maxwell relation we cannot write directly till T V at constant P. Okay.
ओके
So Maxwell relation can be written like this, not
अगर
like
यहाँ पे
this.
एस होता कांस्टेंट.
Yeah. Okay. So that's the thing.
ओके
Okay. Now this question is important one. It says, for which set of delta H, means change in enthalpy and change in entropy, will the reaction be spontaneous only at higher temperature? Okay. Now if you follow the lectures in the beginning, sorry, we said that for del G to be this, we need to be, so for del G there is del H. Okay, so let me just do for del H, then it will be okay. Okay, so our equation was TdS minus du minus PdV greater than 0 for spontaneous change. Now H enthalpy is U plus PV, So del H will be del U plus P del V plus V del P. So if you write it as del H, so there is del U, P del V, so V del P. So if you write it as T Ts for at any temperature, okay, let me just do it in another way. So TdS minus du plus P del V greater than 0 plus minus PdV. Okay, now if we fix VdP, sorry, V del P, if we fix P constant, then it becomes T del S minus del U plus P del V. That is del H, so it becomes greater than 0. T del S minus delta H at constant P, this is also constant P, greater than 0. And we can reverse it, del Hp minus T del Sp less than 0. Now delta Hp, or it is written as first option. Let's check first option. So first option is, this is 70 kilojoule, so this thing needs to be negative. So if this means 7 into 10 to the power cube joule, and delta S is 30 joule per Kelvin, so to make it, T must be 70 by 30 times 10 cube Kelvin. So this is high temperature, so both needs to be positive. If del A is also positive and del H also positive, then means this needs to be positive, del H needs to be positive, that's why both. And if del A is negative, then that is criteria is fixed. Now this is both are positives, and at higher temperature, means at high temperature T del Sp then will be more
Hello, sir.
negative, so this option is right.
Sir,
But yes.
सर जब आप ये बता रहे थे डेल पी अपन डेल एच, तो यहाँ पे नेटवर्क की वजह से आवाज वो नहीं आ रही थी मुझे,
From okay,
तो जब बताना यहाँ से जो आपने बताया.
so del H is, then after taking the differential, will be del U plus P del V plus V del P. Now del Hp means del H at constant pressure will be del U plus P del V, and if you write in this thing, then this expression,
सर ये यहाँ पे नीचे जो नीचे यहाँ तक हो गया था ना टीजीएस, यहाँ तक इसके बाद डेल एच माइनस माइनस टी डेल एच.
oh okay, so after
तो
this,
नीचे बॉक्स में बंद किया है ना ये यहाँ
so after this, now the question says that when the reaction will be spontaneous only at higher temperature. To be higher temperature means this thing is quite high. Now to make it higher, delta Sp needs to be positive, right? Means if delta Sp positive,
Yes.
then T del Sp minus T del Sp is more negative, then this will be get less than 0. So delta Sp will be always greater than 0. Now option greater than 0 is only 1 and only 2, but for this, hello, so this is not correct, this is not correct. Now between these two,
यस सर, कुछ नेटवर्क प्रो इशू हो रहा है आज, पता नहीं क्यों.
Okay, now for option A, option D, last option is always correct because del H is 0, and if del H is small, very small or very high, this and also positive, this thing is always negative. This thing is always negative. This thing is always negative then. So this option is always valid. But here the question says only at higher temperature. So only at higher temperature, for that this option will be correct. Only this option will be correct. Okay. So that's the thing. Okay. So let me go to the next problem. Next problem says the correct thermodynamic relation is given by del Cv del V at constant T is equal to plus R, del Cv del V at constant T equal to 0, del Cv del V at constant T is equal to minus R, del Cv del V at constant T is equal to plus 1. Now to do this, we have to know what is Cv. Cv, as you all know, Cv is dq T at constant
I'll
V.
you solve, sir.
Yes? What are you saying? Hello? So,
Nothing, sir.
yeah.
Nothing, sir.
So, Cv is written as like this. Now, as you all know, then del Cv del V at constant temperature, then that becomes del by del V T del H del T at constant V at constant T. Now how can you write it? We write it like this: del T del V at constant T times del S del T constant V, or T del 2S, sorry, del V times del S del T at constant V and constant T. Now this is 0 because T is there constant. Now to make it 0, now you say here Vt both are constant. So Vt both are constant and there is V and T. So this is also 0, right? How can you write it? So del S del T has function T, and if you do that, that will make a function of V only, and V is not there. So now when you do it del V at constant T, that will make it 0. Got my point? So then this becomes 0. Okay.
So please again say why it is 0.
So Cv is T del S del T at constant V. Now when you write del Cv del V at constant T, then we can write del V at constant T, and this is the expression. The first term is 0, means del V at constant T is 0. Now plus T del V, and then del S del T at constant V at T, that is constant T, so that is 0. Now if you write it like this, sorry, S P T V, sorry, this is not possible here. So the only argument that I can give you right now is when you are differentiating with respect to T at constant V, and now you are changing with respect to V, so there is V constant, right? V is constant.
Right.
Now you take the derivative with respect to v, that will make it 0, right?
Okay.
So in that way we can write these two terms as 0, so that will make 0. Okay.
Okay.
Okay. Okay. So let me go to the next thing. Now, problem 9 says the correct thermodynamic relation is given by del Cp del P at constant T. So now it is with respect to P. So now write Cp in the same manner. Cp will be T del S del T at constant P. Now if you take del Cp del P, so del Cp del P at constant T makes it, so del P, so there is no, we can keep it, T is not function of P, so T you can take outside, del P del S del T at constant P with constant T. Okay, now if you write it, then it becomes T, you can change it, T del T del S del P at constant T and P. So this is like changing the variable. So this is exact differential of P and T. Now we just changed. Now we are differentiating with respect to P first, keeping T fixed, and with respect to T first and keeping P fixed. Okay. Now
Okay.
now this is right. Okay. Now this is SP TV. This is SPT. This is like this. So del S del P at constant T is equal to minus del V del T at constant. So we can write T del T and del S del P is equal to minus del V del T at constant P and constant P, and this is P. So this is times, right? This is okay. Now we can write T minus T del 2V del T2 at constant. So this is the right answer. Simple algebra. So option D is the correct answer. Minus T del 2V del T2 at constant P. Okay. We can actually write this thing also same way. So this is del V del S del T at constant V at constant T, that we can write del T del S V at constant T and constant V. Now if you take it SP TV, then del S del V at constant T means this one will be del P del T at constant V. So it becomes dd del T and del P del T at constant V, and this is del 2P del T2. So for ideal gas, del P del T2 is 0 at constant V. That's why also 0. Okay. So same thing. Here is also the same thing. So the main theme is also the same. Okay. Now option 10. Correct thermodynamic relation for ideal gas is given by, too many options is there. Now to do that, we will take the relation of Jacobian relation. Okay, Jacobian relation is something if you follow the lecture you can know it, but here I will give you some brief introductions. Okay, so Jacobian del, written as del xy or del uv del xy, it is a matrix where written as del u del x constant y, del u del y constant x, del v del x constant y, del v del y at constant x. Okay, now if you make v equal to y, then this thing becomes del uy del x del y becomes del u x y del y y x del y x y and del v y x. Now if you make it, then it becomes, or you can write in different manner also. So let me write it in del P del T at constant V. So del u, so here V is y, right? So V is y. Here u, this is u, V is y. So it becomes, first thing, this is multiplication, this 2 times this. So del u del x with respect to y plus del y del x y del u del y x. Now del y or x are independent, so this will be 0. So this we can write del u del x y. This is one way we can redact the thing. Okay. Now if that is the thing, now how can you write, just see this thing. So how can you write del p del v t? So here u is p, x is v, y is t. So we can write is like this, del pt by del vt, like this. You can write this. Okay, this is true. Just the same thing, we just change the variable and we rename it like this. Now there is also one relation, chain rule. So we can change any variable here and means like del p del t, we can like this del p del t, and so del p del t, and we can write, let's say see it, one relation is if we change one order of one variable, that comes minus. So let's change the order tp. So we have changed one order tp, it will become del v del t. Now to make this at P, let's say what I've said, that chain rule, del T del P at d vel P Vp and dVp delta Vt. So this up to this point there is no problem, right? Okay, now we can write del P del V. I will go through this derivation once again to make the thing simpler, but let me just derive it first. Okay, this become minus del Tp del T, sorry, del Vp and del Vp del Vt. Okay, now just changing the order of this thing, that will make minus, one more minus, and changing order of this thing, that will make one more minus. So we can write minus of del Tp del Vp times del Pv del Tv. So this is one thing common, so that will be in the denominator. So in this same thing, y is common, that will make del u del x at constant y. So here P is common, means del T del V at constant P, and here V is common, so del P del T at constant V. Now that makes del P del V at T times del. Now if you get this one here, that will be inverse of this, so that denominator thing will go in the numerator and numerator thing comes into the denominator. So there will be del V del T at constant P and del T del P at constant V equal to minus 1. So this is the answer. So correct answer is this one. Okay, now let me go through this calculation again. Okay, just a minute. Okay, now this is called a Jacobian method. So the notation is del uv del xy. It is written as del u del x at constant y, del u del y at constant x, and del v del x at constant y, and del v del y at constant x. Now if you just change one variable v equals to y, that reads uy xy, means second term in numerator and denominator are equal. Then you can write del u del x at constant y, del u del x at constant y, and del u del y at constant x, del u del y at constant x, and second thing del y del x at constant y, and del y at constant x. And now if you take the multiplication, that becomes del u del x at constant y, del u del x at constant y times del y at constant x, and del y which is 1, so that becomes del u del x at constant y, and these two things, so this will be minus. Okay, this will be minus. So for this thing, del u del x del y del x at constant y times del u del y at constant x, and now y and x are independent variables, so del u del y del x at constant y will be 0. So now the notation becomes, if two variables in the second terms are equal, we can write del u del x equal to y, means del u del x and constant term is y. Now since del p at constant t, in the same manner we can write, seeing this and this uy, so means u x is there, so that will be in the numerator and denominator respectively. So p and v respectively, and the constant term will be common for both things, t and constant. Now one other information, now if you change the order of this thing p and t, that will bring one minus. So I have changed the order. We have bring t first and p second, so that will induce one minus, so that becomes del t, del p, del v, del t. Now chain rule says if I change one variable here and then it becomes, so changing one variable del tp, del vp, so one variable t here substitute by p, so this term will come here del v, del p, and this term will be there. This is the thing. Now if that is the same thing, using the same relation, it will become, so this p common, so there will be minus del t, del v at constant p, and here v is common, so del p, del t at constant v. And if you take here, that will reverse of that, so this called reciprocal relationship. Just let me written. So del t, del v at constant p will be del v, del t at constant p minus 1. So if this is minus 1, del v, del t p at constant minus 1, so if you go, if it comes to the right hand side, left hand side, so that becomes del v, del t at constant p. Okay, so this is the same thing, so minus 1, so this will come here, del v, del t constant p, similar to for this del t, del p at constant p, minus 1 is there, so minus 1. This is a big derivation, so but there is nothing but the algebraic manipulations. Okay, so just go through the calculations again and you will get to know.
ओके एंड हाँ, हमें भी ये जब कॉलेज में कराया था वहाँ पर साइक्लिक रिलेशन बता के हमें सिर्फ
Exactly.
इसका वही बताया था, डेरिवेशन नहीं बताया था.
So cyclic relation means, okay, I will just once. So cyclic relation is मतलब if you, तुम अगर इसमें करो, मतलब सारे calculations करो, तो उसका वो आता है. So here this is p, v and t, and if you do the cyclic relation, means del p, del v, del p, del v at constant t. The next term comes any one of this thing, del t, del p at constant b. So other thing keeping constant, then other thing comes del p, del t at, sorry, del p, del t same thing, right? This will be one, only thing was del v, del t, right? Del v, del t at constant p. So for the cyclic thing, this will comes minus 1. So p, v, t, so taking one differential, other constant. So if you do the thing same again and same again, that will give minus 1. This is called cyclic. But the derivation comes from here. Okay. Okay. So now these are all on Maxwell relation. I expect Sachin you to do this. So first relation, you need to calculate del v, del t. So just calculate it for me. S p t v. So vt calculation, vtp in this direction. The other direction will be from Sachin?
Yes.
From S to? From S to?
S to T.
S to T, yes. Now tell me, so for this thing, this is an upward, so this will, it will
Yes.
be negative, right? Del v, del t at constant p.
नेगेटिव पॉजिटिव आएगा ना?
No. I said that if the final position from initial position in the upward direction, then we will consider the convention as negative.
Okay.
Similarly, for this one is positive. Okay, this is downward.
Okay.
So this will be del s, del p at constant t. Now just here, this option is not right. This option, lets me check. This is also not right because this is vt and this is st. This is also not right. Now this, for this thing, this is right? So this is the same
Yes.
thing. Yes. So option 1 is correct. So in this way you can do it.
कितना इजी हो गया,
Yes. What do you say?
कितना इस तरह से कितना इजी हो गया,
Yeah,
नहीं तो
yeah.
याद करना बड़ा मुश्किल पड़ जाता है, नहीं
Yeah.
याद होते भी नहीं थे।
हाँ. But you need to आपको अगर ये पूरा कन्वेंशन पूरी तरीके से याद रहना चाहिए। मतलब जैसे कि आप बोल रहे थे कि डाउनवर्ड अपवर्ड, तो मैं उसके लिए लिख सकता हूँ एक्चुअली। सो आई विल राइट इट। ओके, सो फ्रॉम इनिशियल टू फाइनल, if it is downward, then positive. If upward, then negative. Okay, that's the thing. Okay, the next problem. Next problem says correct thermodynamic relation. Same thing, but here you have to calculate the thermodynamic relation. So the first, so since here it is with respect to u, let's write u. U is a function of s and v, right? U is a function of s and v. Then du will be written as del u del s at constant v dv ds plus del u del v at constant s dv. Now this is tds minus pdv. So I have given some mnemonic diagram like this. Good physicists have studied under very fine teachers. And if you have to write, let's say you have to write this du, right? Sorry, v, this is v, du, right? So the convention is like x coordinate. So you will first write like du is equal to, so there are neighboring variables. This is the neighboring variable for u is s and v. So ds and dv. Now since this is in the positive x-axis, so this will be positive. This is in the negative y-axis, so this is positive y-axis, so positive. So this is plus. This is negative y-axis, so this next x-axis, that's why minus. Now we have to we have to multiply this thing with respect to its canonical conjugates. Now S entropy's canonical conjugate is temperature, Ts, to make it the dimension of energy, and for V this is P. So this is the way you can easily write. Okay, so this is the thing. Now you have to calculate del u del V. So del u,
इसमें साइन वाला एक बार और बता, मुझे साइन का समझ में नहीं आया, इसमें क्लियर नहीं हुआ।
साइन का कन्वेंशन ये है like xy coordinate. So if this is the point and in the x direction, if it is positive, the nearing variable, then that will be positive. In the y-axis, if it is in the negative y-axis, that will be negative. So for u, the neighboring variable is s and v, right? If you take,
Right.
so this is the way. Sorry. So for u, this is in the s is in the positive direction, that's why positive, and v is in the negative direction, that is negative, that's why. So this and this, that's why positive negative. Okay, understand?
Okay. Yeah.
So now du del Vt at constant temperature. So constant temperature means this T will not be differentiable. So del S del V at constant T and minus P. So del V. So with respect to we are differentiating du with respect to V. So this is become T del S del V at constant T, and del V is 1, so minus P. Now the same thing you tell me SP T V. So SVT, what will be the other thing? How can you write it? Del S del V at constant t with respect to other relation. Tell me, you just say.
Is del P upon del T
Del P upon del T
constant B.
constant B. Right?
Yeah.
Now here
Yeah.
this both are downward, so no problem in signing. So
Yes, sir. Positive.
minus P. So option D is correct option. Okay.
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 एक मिनट सेकंड, जैसे जो हमारा पिछला वाला क्वेश्चन था, अगर हम इसको डेल अपॉन डेल एस से इसे वो करें वो डिफरेंशिएशन, तब क्या वो आएगा रिजल्ट?
किसके रेस्पेक्ट टू डिफरेंशिएशन करना है?
डेल यू अपॉन डेल वी को अगर हम डेल अपॉन डेल एस,
डेल यू अपन डेल एस करना है ना, with respect to which? What is fixed?
ये
Now here you have differentiate the whole thing with respect to V, but keeping T fixed. Now if you give me one thing that you are differentiating with respect to S and keeping other thing fixed, then I can give some.
ये एक्चुअली ये नहीं है, जो अपना असाइनमेंट है अपना उसमें है, तो मुझे इसमें समझ में नहीं आ रहा था ये.
What was the
इसलिए
question?
मैंने
What was the question?
क्वेश्चन उसमें इनकरेक्ट मैक्सवेल रिलेशंस फाइंड करना था.
अच्छा, तो अगर इनकरेक्ट होगा तो इनकरेक्ट, तो उसके लिए देखना पड़ेगा कि कैसे कैसे हो रहा है. अगर तुम क्वेश्चन मेरे को बता सकते हो तो मैं बोल सकता हूँ.
हाँ, एक सेकंड मैं आपको भी बताता हूँ.
Yeah. Just a minute. I will write it. Okay. Just keep it like this. Del u, del 2u, del s, del v is equal to del tv s 1 del 2h del s del p is equal to del v del sp and del 2u del tv is equal to minus del s del tv and del 2g del tp del 2 minus del s del pt. Okay, I understand the problem. Okay, let me solve it for you. Now whenever at first check what is the functional. Now the functional is u, right, for first case. Okay, so u is written as this usv. Okay, now first question says del 2u del s v. Now del u del v, what is del u del v is equal to at constant s is p. Okay, now you have to check what is now the relation that needs to be proved, that is del t del v. So we will keep this thing contact, we will write del v del u del s keeping v constant, right? This is the meaning of this thing. This is the short notation, this is the same notation. Now del u del s at constant v, del u del s as constant v is t, right? So that becomes del t del v at constant s. So this is correct relation. Did you understand my point?
नहीं,
Huh?
ये मैं समझ में नहीं आया आपने किस तरह से वो किया.
Okay, just follow me. So this is del to u, del s, del v. This is
Okay.
called. So we will first. This is a partial differentiation with respect to v and with respect to s. That is correct, right?
Right.
So this is a short notation. We can. The meaning of this thing is this. Means when we are taking the partial differentiation with respect to one variable, we will keep other variable fixed.
Okay.
Now, since these are exact differentiation or exact differentials, we can exchange the order of the differentiation. Here, first differentiation with respect to v, last with respect to s. We can write it as फर्स्ट पहले हम लोग एस के रेस्पेक्ट में डिफरेंशिएशन करेंगे, उसके बाद वी के रेस्पेक्ट से करेंगे. सेम थिंग, राइट? सो नाउ वी हैव रिटन विद रेस्पेक्ट टू डिफरेंशिएशन विद रेस्पेक्ट टू एस, कीपिंग वी फिक्स्ड. नाउ लेट टेल मी when you are differentiating u with respect to s, keeping v fixed, that is t, right? From this relation.
Yes.
Now this term becomes d, so that becomes del t del v at constant s.
Yeah. Right.
So two things you need to remember. Okay. First thing, for exact differentials, the order of partial differentiations does not matter. So whether you are taking differentiation with respect to v first or s first does not matter. Now depending upon the options given there, now the option says that del t del v, so I got the clue that I need to keep del v later. When I need to differentiate with respect to s first, that's why I have arranged it like this. I have arranged del u del s at constant v first, and then we are differentiating that term with respect to v. That's why now taking the relations del u del s at constant v is equal to t, we can write it easily. Okay.
Okay.
So this is the thing. Now that comes after lots of practice. After doing too many practices, you can solve those problems very easily.
Yeah.
I saw those assignment problems, but I think the problems that I have given here, those are more holistic and more difficult than those problems. Those problems are coming just straightforward to all those things. That's why I have given those things here. Okay.
Yeah.
Okay, let me go to the next problem. Next problem says correct thermodynamic relations. So again here the free energy is A is called Helmholtz free energy. A is called Helmholtz free energy. Now Sachin, tell me here A or A plus similar. Tell me from this diagram how A can be written, or dA can be written. dA, differential of A, can be written. Let me write here.
FT.
So then dA equals to dV and dt.
Yeah.
Now what? This direction is positive or negative?
And negative.
So dt will be negative, and this direction negative or positive?
Negative.
Negative. So this is minus. Now what is the conjugate variable of V?
VP.
No, conjugate variable of V. What is the conjugate variable of V?
B का conjugate P1
P. Oh, I heard it T. What is the conjugate variable of T?
S.
S. This is the relation.
Yeah.
Okay. Now we can write P as del A del V at constant S minus, and S as del A del T at constant V minus. Do you agree up to this point?
Okay.
Do you agree up to this point?
Yes.
Okay. Now what is CV? CV is T del S del T at constant V, right?
Right.
Now S is written as this, right? Just replace that del del T minus del A del T at constant V by V. Now what it becomes? Tell me.
Uh, S.
S. Why S? S I have replaced by this. So
Yeah.
this is double differential. So del 2 double differential del 2 A नीचे double differential with respect to T.
Del
So del T2
G.
at
T
constant
square.
T. So this is the correct option. Pretty easy, right? Same thing.
एक सेकंड, यहाँ पे जो जैसे जो कोस्टेंट का वो क्या है हमने P, ये कैसे यहाँ B है ना यहाँ पे तो?
हाँ, this is V. V. Okay.
हाँ.
I just did it in minus. So
Okay.
I marked it correctly, but I mistakenly written. Okay.
Okay.
Okay. Now tell me this one.
CV. तो del T upon
So you get this one, right? S is equal to minus dA dt at constant V, right?
Okay.
So I will use this relation. Okay, here S is equal to minus dA dt at constant V.
B.
Now here the relation, or sorry, here the relation is says CV. CV is d del S del T at constant V.
Del
So here
B.
we will use other relation, that other Maxwell relation. So we told you, then if it is like this, then how can you write it? So S can be written here, T will be in the denominator, and the fixed term will be common here.
B.
Okay. Now
Yeah.
now the same thing can be written with respect to others. How can you write this? Let's just change their order. That will become minus del Vs del T V. So since we have changed the order, it has become minus.
Okay.
Now to make it with respect to V, so here there is S fixed, V and T. So to make it there, I will write it as del V S and del T S. Now del T S was not there. I have included it. So I have to use the chain rule, del T S, del T V. Right?
Right.
Now this thing is the same, del V del T at constant S, and this term can be written as del S del V at constant T.
Yes.
Right? So
Right.
CV becomes minus T del V del T constant S del S del V at constant t. But here the other variable is S, right? So we have to use Maxwell relation SPTB. So SVT will be like this, all are downwards. So tell me what will be the final expression? Del V del T at constant S. So we can write del S del
del
V
P
del T is equal to del P
del T
at constant
constant
V. So we can write it del P del T at constant V. So what is the correct option? Tell me.
yes.
What is the correct option? Tell me. This one?
Fourth.
Why fourth? This one, right?
Sorry, second minus.
Okay, the last option. Correct thermodynamic relation. So alpha is, how alpha can be written? Alpha is the del V del P at constant T, and KT isothermic, this expansion coefficient del V del T at constant P. Now if you take the ratio of those two, alpha by KT kappa T, that will become del V del P at constant T times del T del V at constant P, right? And one minus will be there. Up to this point, can you follow it? I have written it correctly. Sachin?
Yeah.
Yeah. Now we will use the cyclic relation that you have said. So Vp is done, TV is done. Only thing is left PT, means we write del V del P at constant T, del P del T at constant V, del T del V at constant V is equal to -1.
-1.
So that becomes del P del T, del V del P a constant T and del T del V constant P, minus of that
-1 upon
del V del P
del
at constant T, del T del V at constant P will be del T del P at constant V. Right
yes, right.
or wrong?
Right.
Then what will be the answer? Del P del T, in the option there is del P del T, but I am
del B del T del V ये रहा माइनस इधर आया बट मुझे केवल del T del V सही है तो माइनस del T del V
where we have gone wrong. Del P del P at constant T, del P del T at constant V, and del T del P at constant. Let's use another method, but in this method that should be done. Or we can use another thing. Okay, just check. Okay, del P del V at constant T times del V del T at constant P times del T del P at constant V is -1. So just fix it here. Let me just add one page. Okay. Then we can write this expression as alpha by k kappa t. So -1 can be -1 can be replaced by this thing. So del P del V at constant t del V del T at constant V and del T del P at constant V times this one minus del V del P at constant T del V del P at constant T and del T del V at constant del T del V at constant. Now if you take this one and this one, these are the inverse of that, right?
Yes.
So anyway, it's coming del T del P. Have I make some mistake or?
हमने जो पहले लिखा था ये तो सही था.
हाँ हाँ वो तो सही है, सेम ही तो चीज है ना, सेम ही चीज है. del P del V del P del P del T del P. But we are getting some ulta, you know. Let's try to do it in another way. Okay. Okay. There is some mistake. Okay. The mistake is here in the definition. So alpha is del V del T at constant P. This is del V del T at constant P. And this is del V del T at constant T. So this is a problem. Okay. That's why the problem comes. So this will be del V del T at constant P and del P del V at constant T. Now if you use this in relation del P del V at del V del T, then it will be just alpha by kt will be 1 by del T del P at constant V, and that will make del P del T at constant V. So this is the correct option, right? Right?
Right.
So if I do the same problem here, then let me just clearly write it. So the problem says in this way, we will write in this way, Pt from V. So del P del T as constant V is del T del V at constant P, and then del V del P at constant T. And the other relation is del V del T at constant P and del P del V at constant T. So this cancel out, this cancel out. So this is the correct option. Okay, that's it.
यही सेम क्वेश्चन असाइनमेंट में भी है.
let me just yeah, just let me just okay. So that's the end of the session, and we will meet for the last time on the 25th or the next session. Let me just stop the recording. Okay, thank you.